Well, great. It's nice to have you this evening. My name is Mitei, a teacher of chemistry over a long time. So this evening, first of all, allow me to welcome you and to thank you for joining us once more for this very interesting chemistry lesson. It will be roughly a 1 hour lesson in which I'll take you through the periodic table, which of course is a very important area in chemistry. Bearing in mind that it is one of the most well set topic out of the 24 topics that we have in high school. For those who are doing it for 4 in Kenya, we actually have a periodic table coming as the first topic in Form 2 under atomic structure and periodic table. So, ladies and gentlemen, I'll take you through this lesson. Just sit back, enjoy, and let us be keen so that we do well in this particular area of chemistry. Now, what I want to tell you is that this periodic table is not just an area which is different or which is segregated from others. There are other relatable topics in high school that are related to this particular area that we are tackling. First of all, let me just start by saying that there is 100% chance that this topic will be asked in exam together with other related topics, which include chemical families, which is a topic that comes immediately after the periodic table. At the same time, we have structure and bonding, a very, very integral topic in chemistry. Then, of course, we have trends across period three. Now, next on our slide is that we look at KCSE 2024 just to act as an example to others. Under periodicity, we actually had 6 marks in paper 1 and 11 marks in paper 2, giving us a total of 17 marks. Now, if you consider that chemistry theory papers, that is both paper 1 and 2, it is totaling 120 marks. Having 17 marks thereabouts is quite significant. It can really make a great change in the grade that you're going to get in chemistry, which by the way is a very important subject in high school. Um, of course, among the other topics that I showed you quickly, that these 5 topics are what you call D and E eliminators. Say that as a student, especially we are not so good in chemistry, focus on them to avoid scoring a D or even worse, an E in chemistry. And my advice as an examiner, as a teacher of a long time in chemistry, is that focus more on Form 4 topics, Form 2 topics, and of course Form 3 topics. Now, when it comes to Form, chemistry carries very little marks, and candidates should not necessarily spend a lot of time on Form 1 work, which of course most of the students anyway take them or take it as a simpler content, so they are easy to understand because the content is still shallow and they might easily understand. So candidates should focus on those topics that are likely to give more marks. Remember that when you go for an exam, your idea is to get as many marks as possible. So that is why you focus on those topics that can give you more marks. What is also very important in chemistry, because I'm also doing this for those who are in Form 4, is that chemistry mastery of content, just having information at your fingertips is key to passing chemistry. Ensure that for any area that is tested, you have information already. And for you to master contents, kindly read a lot of your notes and understand. Do a lot of research on various topics. Revise a lot. And that is why I insist that students should actually write notes. Most of the students, by the time they are in Form 4, they actually don't have their notes that they wrote back in Form 1 and 2. Yet KCSE is a cumulative exam that tests all areas. So let the students ensure that you have all these all your notes for you to prepare for exam. Sometimes back I was in a school that insisted that before you do a major exam, you should at least have read your notes, the 24 topics, 7 times at least. I don't know how many of you have already read their notes that much, especially for the Form 4s. Avoid over reliance of mocks from the so called big schools. Um, Instead, revise your content. Of course, I'm not saying you don't look at those questions because, again, you need to test yourselves, to examine yourself, so that you're able to access the point at which you are at any given point. Now, let me say that a periodic table consists of groups of elements and even periods. Now, elements are actually arranged in a column, and in a standard way in chemistry, you should write these groups in Roman numbers. Roman 1, Roman 2, to represent actually the 8 groups that we have. The same 8 groups that we have talked about actually form what we call chemical families, and we shall dwell more on these chemical families, students, in the topic that is coming ahead of us. Actually, chemistry, there are not actually 8 groups of elements. There are actually 18, but because we insist on only group 1 to 8, we, due to presence of transition elements which occupy the rest of the groups, we focus more on the other elements that give us the 8 groups. And what is very important also, students, is that these elements actually have similar characteristics. That is why they belong to the same family. Now, for those of us who belong to the same family, we tend to have some particular characteristics that make us similar. Now, another thing about these elements is that they have the same number of valence electrons. Valence electrons are actually electrons on the outermost energy level, or otherwise what we call the outermost shell. Another thing is that elements are also arranged in periods, which are the horizontal rows of elements. Now, what is important to note about periods is that, periods elements tend to move from one group to another across the period. That is when you start from left and you end up on the right side of the periodic table. And these elements usually do not have similar properties, unlike elements that are in the same group. And what I want you to notice that when we are talking about these elements, we tend to also move from reactive to unreactive at the end of group 8. There are 7 periods of elements in the periodic table, but for high school in Kenya, we only insist on the first 4 periods because we tend to end at element atomic number 20, which is calcium, that ends up in period number 4. Now, valence electrons increase from left to right across the period, and that is why these elements tend to have differences in terms of groups. Thank you so much. This is a sample of the periodic table. I urge the students who are in this meeting this morning to ignore these letters, but what I want you to notice that this one represents the first period, this one the second period, this one the third period, and this one is the fourth period. When it comes to groups, this one is the first group, this one is the second group. This space is occupied by what we call transition elements, and some of the transition elements that you might know in chemistry includes copper, lead, iron, zinc, and so forth. This one is between group 2 and the transition elements. You have group 3. Now, after group 3, we have group 4, then group 5, group 6, and then group 7, and then the last group, which is group 8, which is also the noble gases. Now, which are these commonly tested areas in chemistry periodic table? One is on questions on electronic configuration. We also have drawing of ions, formulae of compounds, that is when elements across various groups combine to form compounds. We need to be able to write the formulae of the compound formed by these elements. We also will discuss uses of some of the elements, bonding of various, the type of bonds that are formed when various elements in various groups mostly join either metals, non-metals, or non-metals together to form various compounds. At times you are given characteristics of an element, like for example the group and the period. Then you are told to show the position of this. It's one of the simplest equations, by the way, in chemistry, and I students to score this very easily. Another thing that we are going to discuss, we are going to look at the trends in physical properties, and these include atomic radii, ionic radii, reactivity, melting and boiling points, conductivity of various elements. And then what I want you to note, and this is very important as an examiner, when you're answering questions on use on elements within the periodic table, what I want you to know is that you need to be able to use comparative language. Yeah? What I mean by comparative language is that we are comparing properties of two elements. Like we asked, compare the atomic radii of element A and B, for example. What I want you to notice that then you should be able to make use of comparative language. You can't be talking about three and you're using, say, A is smaller or something, yet you're talking about three. If you're talking about many, then you should use words like greatest, largest, biggest, and so forth. So this is very important because I've seen students failing to get marks because of not using comparative language in a proper manner. Now let us look at drawing the structure of atoms or ions. This is another area that you'll get as part of the questions in periodic table. When drawing the structures of atoms or ions, first of all, you need to show the composition of the nucleus. That is the protons and the neutrons that are found within the nucleus of that particular atom of an element. And if it is an ion, let me suggest that please you should be able to show the charge of that ion. And for you to show the charge of that ion, whether it's a cation or an ion, you should actually put brackets. There should be brackets. Don't forget to put brackets, otherwise you will lose marks. Now, at times you are told to write electronic configuration of various elements, and by the way, these tend to be one of the cheapest equations that you can ever get about atoms or elements in a periodic table. One, know that energy levels can only accommodate a given number of electrons. First energy level can hold a maximum of 2 electrons. The second and the third can hold a maximum of 8, and that is first 20 elements. An energy level can hold less than a maximum number of electrons, but not more. For example, if it is meant to take, if the second energy level can take maximum of 8, you cannot actually put 9. Though at times we tend to get this mistake being made by students in the course of marking your exams. When an energy level is full, students, additional electrons must be taken to the next available energy level until it is completely filled. Then again, I've talked of ion formation, that electrons must be shown with a different symbol. That is when you are drawing the electronic structure of an ion. Then if the original atom had crosses to represent electrons, then the incoming electron can then be a dot, and vice versa. Then, as I've said, you must show the charge. Okay. Now, again, we talked of subatomic particles, differences between protons, electrons, and neutrons. As a student, you should be aware as part of atomic structure. What are the functions of the neutrons? They, of course, contribute to the mass number of a particular atom of an element. Then, at times, you are also asked, and especially it is for the form 2s, why is an atom? Why is an atom electrically neutral? That is a question I need you to think about. An atom is electrically neutral because the electrons and protons are equal in number. So because they have different charges, these charges tend to cancel out. That is why atoms and combined atoms usually have no charge because of the balance between the electrons and of course the protons. Now, when placing an element in the periodic table, period to which an element belongs is determined by the number of energy levels. I think we have talked about that. The number of energy levels actually determines the period to which an element belongs to. So if an element has 3 energy levels, they belong to period 3. If elements have 2 energy levels occupied by electron, then those elements belong to period 2 and so forth. Now for the group to which an element belongs, it is determined by the number of electrons in the outermost energy level. So very important for students to not confuse period and a group when you're having a discussion. Another question that you ask at times is, of course, why is the position of hydrogen in the periodic table, why is it that hydrogen can belong to group 1 and or group 7? You need to explain. One thing we said that the group of an atom is or element is determined by the number of valence electrons. Now, when you write the electronic configuration of hydrogen, it is just 1. So when it is 1, it simply means that it can lose 1 to be stable. Hence, it can be placed in group 1, or it can gain 1 electron to be stable. That is to form a duplet configuration of 2. Because of this, it can be placed in group 7. Then you should always be able to calculate relative atomic masses, a very common question in exam. Now, that is when you are given percentage abundance of the isotopes or when you are given ratios. At times, you are also given the mass numbers and then the RAM, then you need to calculate the percentage abundance. This is a very tricky question for students, and I ask students to practice on answering this question. What I want students to also note, thank you so much, is that the RAM of a particular isotope is always closest to that isotope with the highest mass, that is abundance. So that, for example, if we have isotopes of mass number 20 and 22, but the one with the mass number of 20 is 70% abundant, the other one is 30%, then it means your RAM or the RAM of that particular element will be closer to 20 instead of 22. When it comes to naming the chemical families, because at times you are asked in exams, ensure that you give correct names. Correct names must be given and avoid confusing names of chemical families and names of groups. When you talk of names of groups, we have group 1, group 2, group 3, group 4, then to group 8. But when you are told to give now names of the families, then it is alkali metals for group 1, alkaline earth metals for group 2, halogen for group 7, and noble gases. I also want you to note that these chemical families are actually given in plural. We don't talk of alkali metal. The group is alkali metals. A group is a number of elements, so it cannot be one element, and then we talk of a group. So the same for halogen. We don't say halogens. We don't say halogen. We say halogens. We don't say noble gas. We say noble gases. So let us not make that mistake, because you will not be forgiven when you are marking. Another very important part of this periodic table is what we call periodic trends. And this basically periodic trends, it is trends especially of the physical properties of elements across the period or down the group. Students, kindly note that it is down the group and then it is across the period. So when you are told to explain the properties of elements down the group, please don't talk about across the period and vice versa. And most of these trends, mostly they tend to make use of atomic radius and the nuclear charge. These two, can I say, properties are the ones responsible for most of the trends that we have. As we continue with this discussion, we realize mostly we tend to explain changes or differences in properties of elements like atomic radius, melting and boiling points, ionic radius, ionization energies, conductivity based on atomic radius, and effectiveness of nuclear charge. Now, what is atomic radius? Ladies and gentlemen, it is actually the distance between the center of the nucleus and the outermost energy level. That difference is what we call the atomic radius. Now, very important, there is a difference between the trend of the atomic radius down the group and across the period. Down the group for all elements, radius usually increases. It increases, and this is due to increase in the number of energy levels. When I give you sample questions, you will understand better what I'm talking about. When it comes to across the period, the atomic radius actually decreases. Very important, it decreases. Why is it decreasing? It is decreasing due to increase in the number of protons, which of course attracts the outermost electrons closer to the nucleus, making the size of atoms decrease across. So we can now proceed to the slide having discussed. Now, next thing that we are discussing is on ionic radiance. Now, when it comes to ionic radiance, it is of course the distance between the nucleus and the outermost energy level of an ion. There is a difference between ionic radius and atomic radius of both metals and non-metals. At times, students are made to identify whether a given element is a metal or a non-metal based on the sizes of ions and atoms of particular elements. Now, for you to identify the metal, I want you to know that atomic radius of a metal is usually larger than the ionic radius. This is because the metals form ions by losing outermost electrons. Losing, this is very important. So ions are formed in metals because metals tend to lose electrons to become stable. So because of this, their ions tend to have less energy levels than the atom. So because of this, the ionic radiance, students of metals tend to be smaller than the atomic radiance and vice versa. For nonmetals, there is a difference. They react by gaining electrons. When they gain electrons, the electrons that have already been gained, because remember, electrons are coming into the energy level which already has electrons. This causes repulsion, and this repulsive effect between the incoming electrons and the outgoing electrons will actually make the ion to kind of bulge, and because of this, the ion will be larger than the atom, and that is the difference between the metals and the non-metals when we make use of the ionic radius. So I hope that one is clear, because it has to be, so that it can allow us to move to the next one, which is ionization energy. Now, one thing I want to say about ionization energy for students is that it is commonly asked in paper 1 as a definition. Define the term ionization energy. And ionization energy is actually the minimum amount of energy required to remove an electron from the outermost energy level of an atom in gaseous state. Please, students, you need to remember atom in gaseous state. If you don't mention atoms in gaseous state, be sure that we are not going to accept maybe that answer. Thank you so much. So next we look at ionization energy down the group. For down the group, it decreases. It decreases. Remember that ionization energy only applies to metals, not non-metals, because non-metals do not lose electrons, they tend to gain. So because down the group, we agreed in the other slide that the atoms become larger in size. This reduces what we call the effectiveness of the nuclear charge. In other words, it becomes easier for atoms to lose ions, to lose electrons, when the atoms become larger and larger. That is why for group 1, potassium for elements in top 20 tend to be the most reactive because it has the largest atomic radius, hence it has the least ionization energy that makes it to be very reactive. Now, when it comes to across the period, I want us to note that ionization energy tend to increase. What we know that across the period, we agreed that atoms become smaller. So when atoms become smaller, generally, the effectiveness of the nuclear charge increases. So once the nuclear charge increases, it means the atom cannot easily release that electron. So because of this, we say that there is increase in ionization energy across the period. Another very important thing that I want students to note is that the second ionization energy tend to be higher than first ionization energy for whichever element, because once an electron has been lost by an atom, the remaining electrons are held more firmly because the overall positive charge has increased. Very important, because you will tend to have these questions during exams, and you need to have facts on your fingertips. You need to do well on this topic on periodicity. Allow me to wrap this a bit so that we can continue with the next part. So next is reactivity of elements across the period and down the group, for example. Let us focus now down the group, where I've said that down the group for metals, reactivity increases. So when you go to group 1, we go to group 2, and then we go to group 3. This is where we find metals. We realize that reactivity increases down the group. In other words, if you look at group 1, lithium, sodium, and potassium, potassium is the most reactive because it has the least effective nuclear charge. So this increases the ability to do what? To lose electrons. For non-metals, it is the opposite. Let us take an example of group 7, that is the halogens. You find that if you are comparing fluorine, chlorine, bromine, iodine, fluorine tends to be the most reactive, followed by chlorine all the way downwards. This is because increase in atomic sizes do not favor um, what you call the ability to gain electrons. So it reduces electronegativity basically. So due to decrease in effective nuclear charge, it becomes very difficult for atoms to attract electrons. Therefore, there is a reduction in reactivity. So if you are asked to compare reactivity of chlorine, bromine, and iodine, you will say that chlorine is the most reactive because it has higher nuclear charge, hence it tends to gain electrons more easily. There's also a relationship between reactivity and electropositivity and electronegativity. Electropositivity is the ease of loss of electrons, which applies to metals. Electronegativity is the ease of gaining electrons, which applies to non-metals. So it's the same thing. Electropositivity is the reaction of metals. Electronegativity is the reaction of the non-metals. So the explanation I've given in terms of gain and loss of electrons is the same for both. Then next we have electron affinity, which is almost the opposite of ionization energy. It is the energy released when a neutral atom gains an electron. So when an atom gains electrons, the energy is released, and that energy is referred to as electron affinity. These tend to reduce down the group. First of all, we have said gain of electrons is only done by non-metal 5, 6, and 7. So the ability to gain electron tend to decrease down the group. So because of this, electron affinity also decreases. So if you are asked to compare the electron affinity of, for example, chlorine, bromine, and iodine, chlorine will have the highest electron affinity, or more energy is released when chlorine gains electrons as compared to the others. Then lastly, is about this, is a bit rare, but when students are asked these particular questions, they tend not to do well. Reducing agent, identify the most. It is the same thing. When you are told to identify the best reducing agent, or the most electropositive, or the most reactive metal, or the element with the least ionization energy, it is actually that element which can easily lose electrons. When an element loses electrons, that particular element is a reducing agent. So if a metal can easily lose electron, we say that it is the strongest reducing agent, it is the most electropositive, it is the most reactive metal, it has the least ionization energy. For elements that have these particular characteristics are those in group 1. And for the first 20 elements, the most reactive, or the best reducing agent, or the most electropositive element is actually potassium, because of what we have just said. On the opposite hand, we have the strongest oxidizing agent, the most electronegative, most reactive nonmetal, the nonmetal with the highest electron affinity. It is usually those elements which are in group 7. And for group 7, you pick the element at the top, which is actually fluorine. So fluorine tends to be the most reactive, the most electropositive, and the one with the highest electron affinity. And if you ask what is the reason for that, you will simply say that it has the smallest atomic radius, and it has the highest tendency to actually gain electrons. So students, it is important for you to get this information very well. Next, let us talk about trends in physical properties, and especially in this case, we look at in terms of structure and bonding. For us to be able to look at these trends, we need to be able to make use of the forces of attraction. But before then, let us look at electrical conductivity. Now, electrical conductivity of elements, metals tend to be good conductors. Well, that is group 1, group 2, group 3 elements are very good conductors, while the other ones are poor conductors. Of course, group 4 are semiconductors. Their conductivity is based on the temperatures available. Now, electrical conductivity is done by is determined actually by number of electrons present. So the more the delocalized electrons, the more the element can be able to conduct electricity. Now, because elements in the same group have the same number of delocalized electrons, they tend to have the same ability to conduct electricity. But if you are told to compare now elements in different groups like group 1, group 2, group 3, those ones tend to have differences in conductivity because of differences in the number of the localized electrons. So another common question is where students are asked, why is group 2 better conductors than group 1 elements? It is because group 2 elements have more. Not that in group 2 means there are 2 delocalized electrons in the outermost energy level, while for group 1 there is only one. So because conductivity is determined by the number of energy electrons, delocalized electrons, then group 1 elements are better than group 2. Now, why electrical conductivity decreases with increase in temperature? Of course, what happens is temperature is a form of energy, so it excites the electrons. These make the electrons to move, at times not necessarily in a particular direction, so it interferes with the increase in temperature interferes with the movement of electrons, and in this case it reduces conductivity of most of the elements. Then next, and we are about to finish up, is the melting and boiling point. Now, melting and boiling points is determined by the type of bonds. Now, for metals, the bonds that they possess are metallic bonds, and because metallic bonds are strong, you realize that metals generally have high melting and boiling points. Now, but you see these melting and boiling points, if you are to compare and get a trend, they tend to decrease down the group due to the decrease in the strength of metallic bonds. Of course, the stronger the metallic bonds, the higher the melting and boiling points. But because down the group there is decrease in the strength of metallic bonds, this decreases the melting and boiling points. So you find that for group 1, lithium would have a higher melting and boiling point as compared to sodium or potassium. In group 2, you'd find that beryllium would have a higher than both magnesium and calcium. This is due to increase or decrease in the strength of metallic bonds down the group. However, when you look at across the period, the melting and boiling points increase for the metals that is from group 1, group 2, group 3. Like if we compare sodium, magnesium and aluminium, aluminium will have a higher melting and boiling point because it will have a higher number of delocalized electrons. There'll be increase in the number of delocalized electrons across the period for metals. This will increase the melting point points. For the non-metals, if we were to look at halogen, for example, if we were to look at fluorine, chlorine, bromine, iodine would have a higher melting and boiling points. This is because for halogens and non-metals in general, they have molecular structures which are held by van der Waals forces. The strength of van der Waals forces is determined by the atomic size. So because we have agreed down the group, there is increase in atomic size. That means there is increase in the strength of van der Waals forces, which as a result will actually lead to increase in the melting and boiling point. So in case you are asked a question in which you are comparing this, then I think now we have an idea of what exactly happens. I think that information is good. There are some sample questions on periodic table. As you can see here, we have a sample. And I want students to know that these elements, there are no elements with these particular symbols. So we are just using them for application. However, if you can say replace the element given with a really particular, like for example, D can actually be sodium. So students are allowed to make use of the real elements where they actually can be able to identify. So these are the questions that we are asked in relation to the periodic sample periodic table I have given. There is another sample question here, so you can screenshot the information. So this is also another sample periodic table, and usually will be asked quite a number of questions in relation to this. So once again, these are some of the questions that these are just sample questions. In the upcoming lessons, I'll post more revision questions that will assist you, especially to do your revision. Otherwise, thank you so much for listening to me this evening. It has been a very good lesson. Let me hope you have learned. Let me get your comments and see which area that you didn't understand well. Then we can redo the discussion. Have a great evening and may God bless you. Thank you so much.